All right, good afternoon, everyone. Welcome back to lunch. Welcome to reInvent 2017. We're thrilled to have so many AWS customers and partners here today. We've got an amazing week lined up with over 1,000 sessions. I encourage you to attend as many as you can. I'll be talking today about IoT, about SCADA, brownfield opportunities. I'll talk a little bit about big data. And if you can make it over to the ARIA, we've got numerous IoT and big data tracks there as well. So again, thank you for attending EUT303, Modernizing the Energy and Utilities Industry with IoT, Moving SCADA to the Cloud. My name is Ben Willett. I'm a solutions architect with AWS. I'm based in San Francisco. We're very fortunate to have with us today Arlen Nipper. Arlen is the president and CTO of Cirrus Link Solutions and the co-inventor of MQTT, the core pub-sub protocol at the heart of AWS IoT. So let's get started. We'll take a quick look at the agenda. I'm just going to spend about 10 minutes talking about some brownfield and greenfield challenges and give you a super high-level overview of IoT. Then Arlen's going to come up and talk about Cirrus Link Solutions, the Ignition platform, and the new AWS Injector, and how that brings basically 3 or 4 decades of SCADA data into the AWS cloud. And then finally, I'll come back up and do a quick demo where we'll take a look at a real-time streaming analytics application. Hopefully at the end, we'll have 10 minutes left over for questions, and Arlen and I will both be available after the session if there are additional questions. So let's start off with some numbers. According to a recent MIT Sloan Deloitte report, despite the fact that the first production oil rig went live in North America about 150 years ago, they still rate the digital maturity of the oil and gas sector at about 4.7 out of 10. So we've got some work to do there. Additionally, Forrester reports that 2/3 of every IT dollar spent are just on maintenance, keeping the lights on. That's irrespective of new development. And then finally, it's estimated that 99% of all data gathered in the field is stranded and inaccessible to IoT decision makers. So hopefully as my dad says, no problems, right? Just opportunities. So hopefully by the end of the session, we'll have demonstrated how to unlock that data, reduce costs, and really deliver on the smart grids and smart fields that we've all read about in the trade papers. So when we think about problem solving with IoT, there's several categories. For now, I just want to focus on 2 customer stories. When we talk about revenue growth, there's a company called Wärtsilä. For my Finnish friends, I apologize for the pronunciation, but they're a global marine and energy company based in Finland, and they were able to predict marine engine failure with a 90% success rate using AWS IoT and the Salesforce IoT connector. And what that means is they were able to drive revenue not only on parts, but on service contracts for their customers. The flip side of these opportunities is operational efficiency. And as you'll hear in a few minutes, I'll dive into the Rio Tinto use case. These guys were basically able to lower costs by reducing wear and tear on their large haul trucks and increase operator safety by implementing IoT Greengrass on the large haul trucks, and we'll dive more into that use case in a couple of slides. So quick show of hands. How many people here are familiar with SCADA, are using SCADA here? Okay, fantastic. So a large amount. Arlen wins the bet. Okay, how many people are using AWS IoT today? Okay, great, a fair number. And related to the demo I'm going to show, how many people are using Kinesis Analytics today? Okay, awesome. So you'll see a pretty cool demo in a few minutes. Okay, so we'll talk about a couple of types of challenges. Brownfield, Arlen is really going to dive into this in detail, but what we've seen is billions of dollars of investment in the field with hardware in facilities that have been running for decades with a myriad of sensors and actuators, right? These are pumps, these are temperature, pressure, these are switches and valves, and myriad protocols. I think when Arlen and I were putting the deck together, we came up with 75 different protocols producing this data. And what happens, right? That data winds up in an on-prem SCADA system, and that's kind of the end of the line. It never makes it across the wall to the enterprise decision makers who are running things like CRM, asset management, supply chain, and maintenance, right? So the Greenfield guys are not off the hook either, right? I know it's always fun to work on a Greenfield project, but what do we have there? We've got new energy sources like wind, solar, and storage. We've got new device types, right? We've got new microcontrollers and SOCs coming out almost every day, it seems. We've got new protocols like WebSockets and HTTP2 and TLS 1.2. And then again, we've really got to learn from the mistakes of the past, and we've got to ensure that we bake in security and compliance from the very, very start. We've got to protect this critical infrastructure. So when we think about IoT, there's really three pillars, right? There's devices, which are sensors and actuators. There's the cloud for massive storage, compute, and as you'll see, orchestration. And then there's intelligence, right? This is taking all of that data, doing the analysis, and helping those IT decision makers and those executive decision makers make better decisions faster, right? So what does IoT with AWS look like? This is a little bit of an eye chart. We've built a lot of technology here, and you'll see a lot more of it this week. Again, I can't give you 60 minutes today of IoT, even though I would like to. But basically, if we break this slide down, and we've really just got a few key points to make here. Starting on the left, we've got IoT endpoints. These are your devices, right? These are sensors and actuators. Moving to the right, we've got IoT at the edge. We'll talk about AWS Greengrass and how we've taken the IoT capability off of the cloud and brought it down to operate locally, closer to the infrastructure. We've got the IoT cloud service that you guys know and love. And again, each of these hops from endpoints to the edge to the cloud or via secure communication. We're using TLS 1.2 with mutual auth. Again, security is absolutely critical. And then once we've got our data in the cloud, we can use all of our favorite tools, right? I'll show you Amazon Kinesis today and some Redshift, but we've got Amazon Machine Learning. We've got a bunch of new frameworks we're going to be talking about this week. I think there's over 50 deep learning sessions alone at reInvent. And if you can attend those, this wave is coming bigger and faster than I've been through a few technology paradigm shifts in my career. And the machine learning one is just absolutely astounding at how fast and how real it's coming. And then finally, with those AWS tools, we're able to expose that data to our enterprise applications. And again, these could be visualization tools, whether you're using QuickSight or Tableau, or these could be in-house corporate applications. But at the end of the day, it's actually pretty simple. There's really just three components, and let's take a look at the cloud first. There's really 5 key components to AWS IoT service in the cloud. We've got the device gateway. This is going to allow your devices to securely connect with the AWS IoT service and other IoT devices. We've got the rules engine, which is going to allow AWS IoT to inspect your payload and based on the values of that message, route it accordingly. If your temperature, as you'll see later, maybe you've got a bearing temperature running at 150 degrees, hey, no worries, that sounds normal. If that thing starts to run at 550 or 650, maybe we want to route that to SNS and have somebody's pager go off, because it looks like we've got an anomaly. We've got the message broker for massive message routing at scale. You'll notice that the turbine icon is grayed out, and that's because the device shadow allows us to build IoT applications that continue to operate even when connectivity is interrupted. And then finally, the device registry. This allows just-in-time automatic device registration at scale. So if you're going to put 100,000 of these things out in the field, the device registry is your friend. Okay, so that's just, again, super 30,000-foot view of AWS IoT in the cloud. Let's focus on the device side of things. So what we've done is taken a very, very simple programming model. As you'll see in the demo, it's just a few lines of code to set up an IoT device and begin issuing pub/sub MQTT calls to the service. We've got a pretty rich hardware ecosystem. So we've got the AWS IoT hardware program where we've got over 25 vendors listed on the website today. If you are interested, go up there, see who's there. If you're a hardware vendor, please come up after this talk. We would love to talk to you. And again, that's a growing list. And then we've got a number of SDKs. So as you know, if you're building devices out in the field, for all you embedded C programmers out there, more power to you. I have my deepest respect and admiration. But what we've done it with the AWS IoT services, we've provided a really simple programming model available in numerous languages. So again, we've got embedded C, we've got C++, but we've also got JavaScript, Python, and Java, if that's your environment. Okay, so at that point, I'd like to rest on my laurels and tell you everything was great, but customers came back to us with 3 additional challenges. They said, hey, 40 or 70 milliseconds to the cloud is fast. That's actually faster than the seek time on the first hard drive I ever bought, but it's not fast enough for a lot of applications. So customers asked us to be able to do local processing at the edge, device to device, in the single-digit millisecond range, right? The other thing they asked us for was the economics piece. Not every single payload coming off of a sensor needs to be sent up to the cloud, right? Communication has gotten cheaper, but it's still not free. Additionally, not every payload is interesting, right? I'm a pack rat. I love S3. I put everything I ever generate up there. But the reality is we don't need to store every single byte of data that's generated. So we can process, we can aggregate on the device, and then we can send up to the cloud what's meaningful. And the third is compliance, right? So for HIPAA applications where the device data that's generated off of a patient needs to stay in the facility, we support that too. And so in 2016, we announced AWS Greengrass, and we moved those capabilities to the edge, allowing you to build what we call a Greengrass group, which is a group of devices operating independently of the cloud, whether they're in a connected or disconnected state. And then we brought down the AWS Lambda programming model. So this is exactly the Lambda that you know and love today. Go in there, build your Lambda functions, click deploy, and we move them down to the edge device where they operate locally and at speed. Okay, so we'll dive a little bit into the Rio Tinto case. I'm already behind schedule. But basically, within a couple of weeks, what these guys were able to do was take a single board Intel computer, running Greengrass on it, and some vibration sensors, and mount these in those long-haul trucks, right? So you see these deep borate mines that they operate with these primitive roads. They really beat the heck out of those trucks, and those trucks are not cheap. Also, just as important is operator safety, right? We think a lot about the safety of the guys driving these trucks. And so what we were able to do is put vibration sensors in the truck and using low power radios, beam that information in real time back to the office and put up a heat map and be able to say, hey, you know what? This road is rough. We need to get some pavers out there, some graders, and smooth this out. And the net result of that was decreased downtime, decreased wear and tear on the trucks, and increased operator safety. So just a great success story there from Rio Tinto. And then finally, the intelligence tier. We're going to talk a lot about this later, so I'm going to kind of gloss over this for now. But again, once you've got that data in the cloud, the whole world of AWS services, we've got 90 services. We'll have a whole bunch more by the time you're done this week. And again, run your big data analytics on there with EMR, tons of machine learning going on right now. I'll talk a little bit about Redshift, our petabyte scale data warehouse. And then again, CloudWatch for the operations folks, the ability to monitor these applications in real time. The good news is you don't have to do this alone. We've got a number of partners available today, including Cirrus Link Solutions. So at this point, I want to invite Arlen up here, and he's going to tell you all about Cirrus Link Solutions and the AWS Injector and how we can get that SCADA data unlocked and up on the cloud.
All right.
I think that's you.
Oh, no, we don't switch yet.
Oh, no?
Nope.
Cool.
Cool. All right, well, thanks, Ben. A little bit about kind of my experience, why am I up here, where did I come from? I got out of Oklahoma State in 1978, so I guess I've been doing SCADA for almost 40 years. And I got a job with Koch Industries, working with Koch Oil. So it was pretty cool right out of college, and the nice thing about Koch was if you wanted to do it, they let you do it. And they were just building pipelines from their fractionation facility in Medford, Oklahoma, to Mont Belvieu, Texas, where we were taking ethane and propane. So I got to run the ditch witch, put conduit in the ground, wire up 5,000 horse Westinghouse electric motors, then connect those electric motors to Toshiba vacuum tube starters. From there, I got to program a brand new Modicon 484 PLC. 1978, Modbus had just come out. So then I connected the PLC to an RTU. Then I connected the RTU to a 300 baud Bell 202 modem on multi-drop phone line. And from the multi-drop phone line, I went back to the SCADA host, which was running on a DEC PDP-11 in Medford, Oklahoma. Now, if I look at some of what I'm seeing with, quote, SCADA solutions and IoT today, nothing's changed. Nothing's changed. We're still building out SCADA infrastructure the way that we did in 1978 and probably even before that. Now, the other thing I want to mention, just to kind of set the context, as Ben said, is that I had the fantastic opportunity to work with a guy by the name of Andy Stanford Clark. We were working on a project with Phillips 66, and we were trying to take advantage of the 200 baud bandwidth they had on their first TCP/IP-based VSAT system, and they wanted to be able to run SCADA over that. And the result of that was the invention of MQTT. So what I want to point out is that a lot of times people say, oh, MQTT, that's bleeding edge technology. MQTT was designed 20 years ago for mission-critical real-time SCADA systems. So just to kind of set a context here, we've kind of gone full circle. Now, again, SCADA's been around for 40 years, and I would say we're victims, the oil and gas industry especially, are victims of, they were early adopters of technology in 1978. But the problem is now we've got these legacy infrastructures, and we need to figure out how to put together infrastructure so that we can do two things. One is we can have a better, faster, more scalable, more secure, more reliable SCADA solution, but start looking at some of that 99% data that we're leaving stranded in the field so that we can get that up to cloud applications. Go through this again. Now, if you think about what we're doing today, we've got all these protocols out in the field, we've got all this infrastructure, and what I see day in and day out is we're really trying to take our perfectly good SCADA system, our SCADA host system, and we're trying to turn it into, if I get to point, we're trying to turn it into what we think looks like a message-oriented middleware. The problem is SCADA systems were never designed to be message-oriented middleware pub-sub systems. So how do we get around that? Well, the barriers to entry, the things that we have to think about when I go and I talk to a pipeline supervisor or to a plant supervisor or to a tank farm supervisor is that we've got to convince him that we know how to deal with poll response protocols. That's a barrier to entry. We have constrained bandwidth. Most of the operations bandwidth is neither free nor unlimited. We have legacy applications. We've got the OT-IT knowledge gap. And we're trying to talk apples and apples, but it just doesn't come out that way. And then we've got to come up with migration strategies. I've not yet talked to one customer that would say, okay, Arlen, that's fine. Shut down my SCADA system for the next year, rip out everything, put in all new stuff, and then we're ready to go. You guys might have some of that, but I haven't come across that customer yet. So we live in a brownfield environment. You guys know that. I mean, we've got systems that we're putting in at Phillips and Plains Midstream Pipeline. They've got Modicon 484s that have been out there since 1982. And they still do what they need to do. They're not going to replace them. They've got flow computers. They've got gas chromatographs. They've got all of this brownfield equipment that we need to provide a better solution for. So we've got to come up with technologies and migration strategies that let us get into existing legacy SCADA systems. Now, these are the bad guys, right? The fact of the matter is over the last 40 years, we've invented, and this is just a subset of the protocols, of the poll response protocols that we've had to deal with if you're going to get into SCADA systems and if you're going to try to start capturing some of that information. So what do we have to do to move from a legacy SCADA system into a more modern, more event-driven architecture? Well, the first thing we did, all those protocols that I showed you, let's forget about those. Let's pretend coming into this room that you didn't know anything about legacy PLCs, and then let's come up with this really cool notion. How about we connect devices to infrastructure? And then just let them start publishing all the information that they know about. Flow computer manufacturers can start publishing all of the flow computer information. PLC manufacturers can start publishing all of the process variables, not the registers, not the Modbus registers and the Allen Bradley registers and the Siemens registers and all this cryptic stuff that we've got to deal with, but give us real contextual data, right? And do that in a way that's secure. Now, one of the things, if you don't realize, MQTT is a remote originated connection. So guess what? All of this discussion around cybersecurity and SCADA, well, yes, we're using TLS, but the fact that you're making an inbound connection means you don't have to have any ports open out in the field. A lot of people don't think about that. Now, the next is, like I said, bandwidth is neither free nor unlimited. So let's be very frugal with our data. Let's come up with binary payload representations. So JSON is great, but if I've got a 200 baud VSAT connection out in the field, I can't afford to be taking 500 Modbus PLC registers and converting them to JSON and trying to get them over that bandwidth because it will create a data storm. So let's come up with efficient payload representation. Provide a single source of truth. Think about the way that we put together SCADA systems today. We have, this is a Modbus register, 40,012, and it's a number between 0 and 4095. Well, now you take that number up to the cloud, and the IT guys, the analytics guys are going to ask you, Arlen, what the hell is that? 0 to 409, it's 40,012. Oh, well, if you look that up in the SCADA system, that's suction pressure. Well, why didn't you tell me it was suction pressure? Oh, well, we could do that. Why didn't you tell me it was 0 to 500 PSI scaled instead of 0 to 4095? What I mean is that we've got to move the tag authority from me trusting that somebody's going to type it in the SCADA system. Let's move it all the way to the edge of the network so that when I publish a piece of information, it goes into my SCADA system, it goes into my cloud application, it goes into my leak detection system, and I don't have to edit it. It's always contextually correct. Demonstrate a superior OT solution. What I mean there is Amazon Cloud is great, machine analytics are great, machine learning is great, but if I can't stand in front of a pipeline operator, a plant operator, and convince him that he's got a SCADA system, a real SCADA system that meets all of his criteria for safety and real-time control, then I'm never going to get a chance to put in this new architecture. So I've got to show him, unlike, and I'm kind of the poster child for how not to sell this, because I tried this for 15 years with IBM, because IBM was, originally, IBM has had MQTT now for almost 20 years. But we never could get to that where the SCADA system automatically implemented MQTT. Provide plug and play functionality, and then eliminate SCADA cutovers. And what I mean there is that now we're talking about pub-sub architecture, so now I don't have to do a forklift, shut down a monolithic SCADA system, bring up the new version, oh, it didn't work, now roll it back. I can morph over one point at a time using MQTT. So my point is that for 20 years, I would say, we've been trying to do this transformation from IT down. And what I'm saying is that what we're trying to do is enable OT, enable the SCADA community, give them the tools and the technology to do what they need to do operationally and then push that information up. So it's not going to be IT to OT, it's going to be OT enablement up to exposing that information. Now, this is an interesting book. This is Accenture wrote a kind of a cool book on Industry X.0. And my point here is that what they're kind of saying is the entrenched players that we all know that are out there, you know, the Rockwells and the Snyders and the Emersons, they've all done a great job, but they've done very siloed technology. It wasn't an outcome technology. It's, you know, this is what we're going to do, and you're going to buy this. But now we have customers coming to us and say, I want to take this service and this device and this information, and I want to combine this for my overall solution. So we're going to have an ecosystem of partners that can put this together. So that list of things I showed you a while ago, let's connect devices to infrastructure, let's define a payload that's efficient, let's make it be the tag authority. Well, CirrusLink wrote a spec on that you can go to our website and you can download. It's called Sparkplug. And Sparkplug is simply it's less than 80 pages long definition of if you're going to do SCADA using MQTT, this is the way you should do it. It's a nice way to do it that we've learned over the last 20 years. And we made that publicly available on our public GitHub site to anybody that wanted to download it. And we did that less than 18 months ago. And since then, these companies have downloaded the specification that says how to use MQTT, and they've implemented it on their OEM devices or on their applications. And what we're doing is we're building up an infrastructure of device manufacturers and application providers that natively do MQTT and Sparkplug into an MQTT infrastructure. So now we're starting to finally we're putting the ability for these smart devices, whether it's Opto22 or a Redline Edge controller or anything from B&B SmartWorks or Advantech embedded Linux computer, and we're starting to put software on there that says, you know what, you're the device at the edge. To what Ben was saying, you know what your process variables are, you know when you should publish those. Now, where we get a lot of the efficiency of using MQTT is the other thing to realize if you read the MQTT spec, and I like to point this out, MQTT provides you state. And if you've read the spec, you see that it's got a death certificate. And what that means is the reason we're getting such good bandwidth reduction out of using MQTT is think about Modbus. I pull, I get the valve status. What's it now? Oh, I don't know. Pull, get the valve status. What is it now? I don't know. Pull, get the valve status. We're chewing up gigabytes of bandwidth polling. That valve hasn't changed in a week, but by gosh, we're polling it. With MQTT, you have state. So once you have an MQTT session, you publish all your information. You publish it once. And now that I've got state, I don't have to republish that valve state unless I go offline or unless it changes. So we're getting 80 to 90% bandwidth reduction over polling protocols or over things like OPC-UA. Now, 15 years ago, 80 to 90% bandwidth reduction meant cost savings in communications. But 2017, that's 80 to 90% more information that we could be sending. Now we're starting to get into some of that 99% of that information we're leaving stranded in the field. So the final piece of this is that we're taking all this technology, and what CirrusLink does is we wrote all of the MQTT technology for a SCADA platform called Ignition. And Ignition has come out here recently. They're a fairly new player, but now we've got a SCADA system that natively implements MQTT the way that I kind of figured we should have done it 20 years ago. And it gives us all of the tools and the capability to put together what I would say is a mission-critical real-time SCADA system. And then we added to that a new module that we just released last month, 2 months ago, sorry, that's called AWS Injector. And now that I've got all this information, all these tags in my SCADA system, now I can take any or all those tags and automatically publish that information into an Amazon Kinesis stream. So if we start looking what that looks like, remember what I said, let's see what would happen if we could connect devices to infrastructure. Now, notice at this point, again, you've got to really get it's almost 180 degrees out of typical SCADA systems. We've got remote connections already done by the devices. They create an MQTT session into a collective of MQTT servers. Again, this is, on-prem right now. We haven't convinced everybody to completely move to the cloud, but they could run these brokers either on-premise or on an EC2 instance. And think about this, is that we've got all that information flowing into an infrastructure. There's not one application that could go down that would inhibit that flow of information into my infrastructure. Then step 2 is I need to show the customer that we can show him a superior SCADA solution. That's where we get to plug in Ignition. Because of the specification I was telling you about, now we can self-learn all the tags. So, for example, we went to Phillips 66 Pipeline. They've got about 1,000 remote locations, 5,000 Allen Bradley PLCs, 1,200 flow computers, 500 truck loading terminals. We plugged in Ignition, and within 15 seconds, it had learned every tag in the system. No more hand editing tags. It had discovered all those tags. Now, I said at this point, you could quit and go home. If you're in front of the operational folks, you can say, okay, you've got a better, faster, more scalable, more available, more reliable SCADA system. Good luck. But now we can start looking at other interesting things like, what about putting together migration strategies into legacy SCADA systems? So now I could migrate off of a legacy system using OPCUA, one station at a time, one device at a time, pull that into my MQTT infrastructure, and then maybe slowly migrate it out. And then lastly, we can add the AWS Injector, and all that information, all those real-time tags that we have going into our SCADA system, we can now publish in real time into Amazon Kinesis. So the demo I'm going to show you, again, as Ben said, we're both trying to take like a 3-hour presentation and cram it into 60 minutes. So the demo I'm going to show you is that I do have Ignition running on an EC2 instance, and we're going to say, pick any device that you guys have. Pick an Allen Bradley Compax Logic, or a Modicom PLC, or a Siemens PLC, or a Emerson Total Flow, or a ABB Total Flow computer. Pick one. And then let's show you a demo of taking that device with the OEM ecosystem that we have and being able to get that information into AWS and do it in 10 minutes. Wouldn't that be cool? And that's really, so everything that we're showing you is real technology. Come up to me later and we can show you how to download all this stuff and do it at home with your Raspberry Pi. So the demo I'm going to do, up here, HDMI 2, there we go. Okay, I have Ignition running on an EC2 instance, and back in Kansas City at my office, I've got various PLCs and RTUs and Heart Smart transmitters, talking different protocols and using these edge devices that I showed you a while ago. So let's go in here, and if I go into my all providers, I have a new provider called MQTT Engine, and inside of MQTT Engine, I have edge nodes, and inside of these edge nodes, I've got different devices. So one of the devices I'll bring up here is a Moxa edge of network controller. Now this Moxa device literally is basically an edge of network cellular gateway. It knows how to poll Modbus TCP, and is polling 5 Modbus TCP PLCs that are out there that are in my office. And I've got an Ethernet switch in there between the last 2 modules. So what I'm going to do is I'm going to publish a command from here. It's going to go to the cloud. It's going to be where Ignition is subscribed to it through this console. It's going to send that relay command in my office, which is going to close an input, and it's going to turn that Ethernet switch off. And so what that's going to happen is it's going to result in 2 devices failing. And what happened because of MQTT and the fact that we've got death certificates, we were able to take all those tags and show them they've gone offline. Now, the other interesting thing that I want to point out here is that at this point in time, if I reset the byte counter, now I'm polling those digital inputs and those relay outputs and those analog outputs, I'm polling those at 100 milliseconds. But look how much information I'm publishing, 0. Because I have MQTT, I have state. But if a relay output changes, which causes the input to change, then you'll see it publishes a small piece of information. But at this point, we've almost got 100% bandwidth reduction, but we're able to see the data within 100 milliseconds over a cellular network. So I'll turn that Ethernet switch back on. And what you're seeing here is a SCADA system. This is what are going out in typical installations. Now, the last thing I'm going to show you before Ben comes up here is one of the things. I've got an Allen Bradley PLC, and I've got a Modbus PLC, and I've got them hooked up somewhat, and don't come up here and tell me, Arlen, that's not quite right, to simulate a pipeline. So we're going to go into this booster station, and under booster station I've got a pipeline, and under a pipeline I've got a pump, a centrifugal pump, and I've got tanks. And these are all complex data types, by the way. And those were all learned automatically when I plugged the edge of network device in. Now, what I can do now is I can come in here and say, okay, I want to do a sequence stop on this pipeline. You'll see the valves will go in transit, the motor will go off, and then our flow rates will come down, and our bearing temperature will start coming down. But my point is that the minute you get the solution in SCADA and you're using this sort of an architecture, now you've freed all that information and can go straight into Amazon and all the services that they've got. So with that, I'll let Ben come up and show you the demo that he's put together using this information. So I will start the pump back up. And I will switch to here. Yeah.
All right, it's going to take me a minute to just get set here.
Oops. Okay. I've got you. Oops.
Okay.
I think I've already got you there.
Okay, great.
All right.
All right, terrific. Thanks a lot, Arlen.
Uh-huh.
All right, so at this point, again, we've got tons and tons of mission-critical pipeline data available in the cloud. You're going to hear a lot this week about the AWS Data Lake architecture. Again, I could do 60 minutes on this alone, but there's just a couple of key takeaways from this slide. The key here is that we want to use S3 as our central repository for data. This can be raw data, unprocessed data coming up like log files. This could be pre-processed data that maybe we've done some massaging of that we want to keep around for historical purposes. And then we want to use purpose-built services to process that data, right? So it's some of the old world, right? I came from a relational database background, and my feeling at the time was, hey, if a relational database doesn't do it, you don't need it. But the reality is I'm out there as a solutions architect every day talking to customers, and when I listen to the challenges and what they're trying to build, we take that back to the service teams and we come up with purpose-built services to solve those challenges. So for example, we've got Aurora for a relational database, but we've got DynamoDB for NoSQL. We've got Redshift for a petabyte scale data warehouse for large scale aggregate queries. We've got EMR, our managed Hadoop platform for data analytics. And again, lots and lots of machine learning. So again, store the data in S3, pull it into the tool that makes the most sense, do the processing there, either keep it in that tool or put it back into S3 for very, very cost-effective, very secure long-term storage. The other thing you'll notice about this slide is the Lambda architecture. This is not AWS Lambda, this is the generic Lambda architecture, where we've basically got batch input, and then we've got streaming input, right? So we've got our batch layer where we're basically saying every certain interval, whether it's minute, hour, day, upload some data to AWS, and then I'm going to run a batch process on it. The lower stream is the streaming analytics piece, and that's the demo I'm going to show you. And that's where we're taking real-time data from the Cirrus Link AWS Injector, running that through Kinesis and operating on that in real time. And then again, for visualization purposes, we've got things like Amazon QuickSight, Tableau, and then for data scientists, if you're one of those RStudio folks, feel free to have at it. Now, we've been talking a lot about streaming ingest, but I want to back up for just a second for completeness and just talk about a couple of other methods. So our friends at GE Oil and Gas have a massive project where they're moving 750 terabytes of data from on-prem equipment up to AWS, and they're using Snowball devices to do that, right? So these are 50, 80, 100 terabyte devices. They've got fiber interconnects on the back. They load them up, they ship them to us, and we securely upload them to S3. So again, for very large data sets that you want to move quickly, Snowball is a great ingest method. We've got Storage Gateway, which is hybrid storage where you can mount volumes on-prem and have those backed up to S3 transparently. We've got great partners like Commvault and Veritas who understand very deeply how to back up data into AWS. And then again, AWS Direct Connect, which provides private connectivity from your facility or colo up to AWS with extremely low latency and jitter. And then again, we're going to talk a lot more about Kinesis Firehose and the injector. So again, you're going to hear this mantra a lot this week: collect, clean, process, store, and analyze. I'm not going to talk too much about these services. I'm just going to dive into the demo and show them to you. So here's the use case. We've got two sources of data, right? We've got the Cirrus Link AWS Injector that's feeding data into our Kinesis Streams application, or we've got AWS IoT, or in some cases both. Right? Once Kinesis Stream has the JSON payload from Arlen, I'm going to run it through a Kinesis Analytics application, and there I'm basically going to run some ANSI SQL over that stream. Just about 3 weeks ago, we announced the ability for Lambda to pre-process that incoming Kinesis Analytics data. So what I can actually do is, as the records are coming into Kinesis Analytics, I can grab them, crack them open, run a Lambda on them, process them, and then put them back in the stream for processing. Again, that'll go to a couple of output streams in Kinesis Firehose, which I'm going to then send through S3 ultimately to a Redshift cluster. We have the opportunity here to use Amazon machine learning. So again, I'm going to talk about bearing temperatures. And again, I have this bearing that I've sort of grown attached to, and it likes to hang out at 150 degrees. I can pass that value from Lambda into Amazon machine learning and say, you know what, just keep an eye on this for me. And if it looks like it's fluctuating in a strange way, come back and let me know, maybe do some predictive analytics. Let me know you think this bearing is going to fail, and I'll roll a truck and we'll go out and we'll do some maintenance. And then I'm going to use two tools to query our newfound data here. Amazon Athena, which basically lets you run ANSI SQL directly against S3, or QuickSight, where you can build really sexy dashboards against almost any AWS backend data source. So enough slides. Let's take a look at the demo. All right, let's see if I can make this happen. Okay. All right, so you've been hearing about it a lot. Let's just take a super quick look at what the actual payload looks like. So again, this is a JSON record. This is one record coming out of the AWS Injector into a Kinesis stream. And again, it's a little bit of a hierarchy here where we've got a topic, we've got a location, it's a booster station, and then the payload is a bunch of metrics. So we've got things like discharge pressure, suction pressure, we've got motor amperage, motor RPMs, we've got bearing temperature, we've got tank levels, all sorts of interesting stuff, right? And now let's go into the console. So I love this time of year because it gives me an opportunity to look silly in front of lots and lots of customers. Go into the console basically every 6 hours from now to the rest of the week, and there's going to be something that wasn't there 5 minutes ago. So the first thing I noticed was this new redesigned Kinesis dashboard, which I think is actually really cool. So over here we've got Kinesis streams. This EUT303 demo is the stream I'm getting from Arlen. I've got a couple of delivery streams. One is filtered, where I'm basically taking a 10-second tumbling window of average bearing temperature, and I'm sending that into a filtered table. And then I've got a raw table here where I'm just sending the entire payload, basically a select star from the stream, and handing that off to Firehose. So let's take a look at what the actual Kinesis application looks like. There was one other point I wanted to make back here. Okay, so again, you can see we've got the pipeline metaphor going here. So we've got basically a source stream, EUT303 demo. We've got our Lambda function here, EUT303 pre-process. We've got our SQL that we're going to run over that data, and then we've got our fire hoses. So let's take a look at the Lambda code here, right? And again, this is just stuff that you guys know and love today. No magic here. And let's take a look at this function code. So basically what we're doing is we're going to get the event, right, that's coming in to the Lambda function that contains the records. There's going to be multiple records in the event. We're going to crack it open, take it record by record. And then, I don't know if you can see this gray. This might have been a mistake here, but I've got some exercises left to the reader, and these are basically use cases that I thought would be super interesting to do in this Lambda function. So the first one is, and again, this Lambda is going to run before Kinesis Analytics gets its hands on this data. The first one is to augment that booster station data with GPS location and weather data. So you guys remember Hurricane Harvey and the infrastructure in its path, right? Wouldn't it be great if this booster station data came down to us with GPS coordinates for the facility and maybe even real-time weather conditions? So for example, is it 1,000,000 degrees there? Is it freezing there? Is a hurricane right in the path of my booster station? Should I worry about shutting it down? Should I worry about evacuating my crew? Do I have an oil rig in the Gulf of Mexico that I need to unhook and move out of the way? Or is this hurricane maybe going to dodge and I can leave these guys safely operating, right? So again, augmenting that incoming booster station data with weather, GPS, et cetera. Augment Greenfield, right? So we'll see an example where I take the payload from the AWS Injector, maybe I do some processing on it in Lambda, and then I publish it to an AWS IoT topic. The third one is predictive analytics. Again, this is huge, right? So I'm looking at all of this data, and I'm able to build some really simple models and basically say, is this pump going to fail? Is this bearing running too hot? What's happening with this truck and this road and this vibration? We can pull out elements of the data and maybe do some math on it, maybe round down some values. Maybe we don't need 5 digits of precision for a certain value. Maybe we want to inspect a value, and if it's running high or low, send it to SNS and have somebody's pager go off. And then finally, I talked a little bit earlier about the simplified device programming model. Again, if you're an embedded C programmer and that's your thing, hey, keep going, more power to you. But we've got a really simple AWS IoT device SDK with a really simple programming model. And I'll show you what that looks like inside of a Lambda function. Basically, we're going to do an include to get the SDK. We're going to set up the device. So what do we need? We need a private key. We need a cert for that device. We need a root CA. And then we need an endpoint, right? And this is my AWS IoT endpoint. From there, I'm able to come down here and with just one more line of code, do a device.publish with the input record from Arlen up to the AWS IoT topic. So again, not too many lines of code here and lots of functionality. But let's dive back into the Kinesis Analytics app. So again, we've got our input stream. We've run it through Lambda. Let's take a look at the SQL. All right. Make sure this stuff refreshes. All right. And basically, Kinesis Analytics, if you haven't used it, is ANSI standard SQL with some extensions that basically turn streams into tables. And then we've added some nice time series data, or time series functions like sliding windows and tumbling windows. And basically, I have two SQL statements here. The first one does select name and average value from the stream where the element is this pipeline bearing temperature, right, tag. And then it's basically a select group by where I take the average bearing temperature for every 10-second window. So I batch up 10 seconds worth of stream data, run the average, return that. Take the next 10 seconds, batch that up, run the average, return that. That's the filtered output stream that we saw earlier. The second SQL statement is basically a select star from stream. I'm taking everything that Arlen is sending, and without modifying it, I'm writing it out to a delivery stream. That's the raw data that you saw in Firehose going straight into Redshift. And that could be maybe just parked in S3 for historical or legacy purposes. Not super interesting there. And again, what I love about the Kinesis Analytics console is it's showing me stuff in real time. So if you look at the source stream, this is actual data coming in from the AWS Injector. And I can keep refreshing this and we'll get more rows. Actually, I shouldn't have refreshed that. It's going to take time. Okay, let me scroll up here. And again, you can see all the values here. So we've got a bearing temperature, motor amperage, case pressure, discharge pressure, RPMs, et cetera. And then you can see the values here. So that's the raw input data. Now let's take a look at once it's been processed by SQL Analytics. So we've run those two SQL statements I just showed you, and we've got two destination streams here. We've got filtered on top and then raw on the bottom. And the filter, again, this is just going to be bearing temperature. This is the only thing I care about right now. This is the tag that I want to track. And you can see we're hanging out at 148, 150, 151. And then finally, we've got our destination. Where are we sending those records? So if I click on my Firehose, we'll take a look at how I've got this configured. Again, Kinesis Firehose is going to do a couple of things for you. One is it's going to take rows from various sources. In this case, it's the EUT303 application. It's going to store it in an S3 bucket called EUT303 demo. I've set it up to checkpoint every 1 megabyte or every 1 minute. So again, these can be as fine or as granular as you want. If you want to do every 15 minutes, you can do that. If you want to do every 128 megs, you can batch it up and then write it out to the destination. But to keep the demo moving, I set it to 1 meg or 1 minute. And then what's the destination? So I've got a Redshift cluster here on the right. I've got a demo database. I've got an EUT303 raw table and a bunch of fields that I want to write to. So again, CloudWatch is our buddy. We've got all sorts of things. You can build really nice dashboards. Apologies to the CloudWatch team if you're here. It's a super powerful tool. You can build really exotic dashboards with it. I encourage you folks to go in there and play with it. And then we've also got CloudWatch logs where we can get very detailed information about what our Kinesis Analytics application is doing, what our output streams are doing, and what that Lambda function is doing as well. Okay, again, all that data winds up in S3. You can see I've got prefixes for filtered and raw. And then I've got my QuickSight dashboard, right? So again, QuickSight has this awesome ability to do introspection in your AWS account. Obviously, you have to opt into this, but I basically said, hey, QuickSight, look at my account, see what you can find. It found a Redshift cluster, a bunch of RDS databases, And I went in and I clicked on the cluster, clicked on a table, and then with a couple of mouse clicks, I just set up this really simple visualization where I'm taking the average value from those tags. And again, I've highlighted my favorite, sorry about the scrolling, my favorite bearing temperature here. Again, still hanging out at about 150 degrees. But let's suppose you're not ready, right? You're new to this and you're thinking, okay, Redshift, I've got to build out a cluster, I've got to pick my star schema, I've got to have my fact tables and my dimension tables. Not really sure how I want to do all this yet. We've got Amazon Athena, right? So this is going to allow you to write SQL queries in an ad hoc way directly against that raw S3 data. And the cool thing about Athena is you only pay for the queries you run, and it allows you to do experimentation, right? So you can say, hey, maybe I want to do average bearing temperature. Maybe I want to do min, max, and average, and I want to store that as a summary table. Maybe I want monthly summary tables or yearly. How do I want to lay out my data mart or my data warehouse? Athena gives you that interactivity without a big upfront creating a cluster, developing a schema, and having to worry about, did I get it just right? Once you've had a chance to sit down and model stuff out in Athena, then you can go back and build out your cluster and build out your really nice visualizations. And then again, finally, in the Lambda function, we saw earlier about how as much as, Arlen and I would love to stand up here and tell you, hey, you know what? Take that brownfield stuff, unplug it, recycle it, and start fresh. We know that that's not always a reality. So one of the mantras you'll hear this week is augment in place, right? Where you can, hey, unplug stuff, and where you can't, then let's modify, let's integrate, let's take these two existing models of AWS IoT and SCADA, and let's bring them together to provide that value to those IT decision makers. And so here's an example of that Lambda function forwarding that JSON payload to this IoT topic. And then again, if you've got your favorite SQL query tool here, for example, this is just running SQL Workbench against Redshift. So really no magic there. All right, and with that, I'm going to wrap up the demo, and it looks like we have just a few minutes left for questions.